All right, guys, here's part two. So hopefully pretty easy. I mean, see the number 50. Hopefully you go, factors of 50. Well, half of 50 is 25. So I'm going to break that down to 25 times 2. Square root of 25 is 5. And the 2 is still trapped underneath the radical. So 5 rad 2 for my simplified answer on there. Hi. Think of 12. You could go 6 and 2, but neither 6 nor 2 is a perfect square. So hopefully you think 4 and 3 instead. Square root of 4 is 2, and the 3 is still trapped underneath the radical. This is one people often go with 8 times 4, and they go, oh, well, it's going to be 2 rad 8, because the square root of 4 is 2. You got to go with the biggest possible perfect square in there. And another way of thinking of that is the 8 would still simplify, because the factors of 8 are 4 and 2, and you could do reduce the 8 again. Think of half of 32 instead. Half of 32 is 16. Square root of 16 is 4. And the simplified version of that is 4 rad 2. You could do 6 times 3 for this one. That's not the most efficient one because neither 6 nor 3 is a perfect square. You do 9 times 2. Square root of 9 is 3. And the 2 stays trapped under there. Now this last one, I throw it on here because there's a lot of people that even after coming out of Algebra 1, they think this can just simplify to 3 plus 4. And they go, well, if the opposite of a square root is squaring a number, these symbols sort of cancel out, and you just get 3 plus 4. And you tell me the answer to this might be 7. If you do PEMDAS, order of operations, you understand that this is a grouping symbol. So you would do what's inside of here first, which means you do your exponents first. 3 squared, of course, is 9. 4 squared is 16. 9 plus 16 is 25. And then when you're done with all that, you take the square root. The square root of 25 is 5, which certainly is not 7. So just be careful with this. When there's a plus sign in here, totally different than this being a multiplication sign. And you've got to actually follow the order of operations and treat this like a grouping symbol. This is going to matter when we start doing Pythagorean theorem tomorrow. The next little section, I've got these things that are wrong. There are people that, even after Algebra 1, make the mistake. They think you can just add radicals. 4 plus 9 is 13, but the square root of 4 plus the square root of 9 is not even close to the square root of 13. And I gave you some of these are obvious examples. Think about what the square root of 4 is. The square root of 4 is 2. The square root of 9 is 3. I just want to show that clearly this is not true. 2 plus 3 is 5. And if you wanted to, you could type this into a calculator, or you could just approximate this in your head, and you could realize it's somewhere between 3 and 4. Clearly these are not equal to each other. So I just want to show you can't add radicals that don't have the same radicand, the same number inside here. Same thing here. You can't do 20 plus 45 and say it's 65, because this isn't 20. This is the square root of 20, which is some decimal, plus the square root of 45, which is some decimal. You can simplify these, which is what I'd like to see you do. Factors of 20, 4, and 5. So that can become 2 rad 5, with the 4 simplifying. Factors of 45 would be 9 times 5. So the 9 would become 3. Now you can combine these. This is just like 2x plus 3x. And you call that 5x. And the one on the right doesn't simplify. There's no factors of 65 that could simplify. These are definitely not equal to each other. If you wanted to show that, you could either type it in a calculator. Another way to do this is to get rid of the square root signs by squaring both sides. If you square this side, you get 65. If you square this, you get 125. Clearly those radicands are not equal to each other at this point. So this is a way to show that these common mistakes don't really work. And again, if these aren't common mistakes for you, I'm just kind of showing you kind of a refresher on why these don't work. Same thing on this one. I want you to simplify these, and maybe that one. Simplify these and just show it doesn't equal what's on the right side. So 9 times 7, the 9 simplifies. 7 times 4, the 4 simplifies. Same thing, 7 times 4, the 4 simplifies. Hopefully you can get 3 rad 7. This was 4 times 7, so it would be 2 rad 7. And this is just plain old. There is an invisible 1 in front of there. So you got 1 rad 7. And of course this is the same thing over here, 2 rad 7. I want you to be able to subtract these. This is just like adding, subtracting variables. 3 rad 7 minus 2 rad 7 minus 1 rad 7. It's a little weird. It's nothing rad 7. In other words, there's no rad 7s left. In other words, this whole side just simplifies to 0. And then we know this doesn't simplify to 0. We know this, we just did it a minute ago, was 2 rad 7. Clearly this method of just adding the radicands does not work. Same thing, try this one. If you haven't already done so, factors of 40 would be 4 times 10. And the trick on this one is when the 4 simplifies to 2, you bring that 2 out and you multiply it by the 3. Everything on here is implied multiplication. And the same thing here, factors of 90 would be 9 and 10. The 9 would become a 3, and it would be 3 times the 2, which is also 6, rad 10. If you subtract these, you get nothing again. So another example where you get 0 on this side. Factors of 50, we did it a few minutes ago, would be 25 times 2. So you could simplify that to 5 rad 2 and show those are clearly not equal. Oh, radical police arresting someone for messing this up. Alright, the last thing on there is squaring and multiplying radicals. I'm going to put this on the last segment here. If you're welcome, you know how to do it, you want to work ahead, go for it. Otherwise, we'll be back in a minute.